I want to solve systems by substitution. In the last video, we did it by graphing. Sometimes when we graph, though, it's not going to be nice and neat. And you won't be able to tell exactly where the point is, especially if we're doing it by hand. So there's actually a couple of algebraic ways of going about it. The first way is to solve by substitution. Remember, our goal is to make sure that we end up with a point, right? An x and a y. So I want to solve for x and then solve for y somehow, some way, right? This is what our solution looks like. It's always where the two things intersect. So if I know that y is 3x plus 5, and I know that y is equal to 2x plus 1, couldn't I substitute this value for y, which is 2x plus 1, and plug it into this one? And I can set them equal to each other. Isn't that exactly what we want it to be, when this one is equal to this one? So I can do that by saying, for example, 3x plus 5, which is this y, is equal to 2x plus 1, this one. So I just substituted it in there, all right? Or maybe it makes more sense if I do it the other way. If I start with this one, and I say, well, if y is equal to 3x plus 5, and y is also equal to 2x plus 1, let me plug that in for this y right here. So it's 2x plus 1 equals 3x plus 5. So substitution is taking one equation and plugging it into the other. All right, I can solve this one. This one isn't too tough to solve. We did this a while ago. Let me subtract 2x from both sides. So that 1 is equal to x plus 5. And when I subtract 5 from both sides, I'll find that x is equal to negative 4. All right, so far in my solution, I have negative 4. Now, if I wanted to find y, couldn't I just plug this thing into either one of these things? If I know that they are related. So let me just use the first one just because it's first. I know that y is equal to 3x plus 5. Now, if I take this 4 and plug it in for x, I'll know that y is equal to negative 4 plus 5. So y is equal to negative 12 plus 5, or y is equal to negative 7. Negative 7. So my solution to this system is right here. Negative 4, negative 7. All right, I can do another one where they're both not in slope-intercept form, like over here in Alex. I have 3x plus 2y equals 7. And then x is equal to 3y plus 6. Well, it looks like it makes sense to me. If I know a value for x, let me take this value of x and substitute it in for that. All right, so I like to draw lines to show I'm about to do some math here, right? This is another example. So 3, and then instead of x, I have 3y plus 6. And then I still have this 2y, and that's equal to 7. So now I can solve this thing for y. So I can distribute 9y plus 18 plus 2y is equal to 7. So we're going back to unit 1, lots of solving here. When I combine these two, I get 11y plus 18 equals 7. Let me subtract 18 from both sides. So 11y is equal to negative 11. I'm going to divide both sides by 11. Y is equal to negative 1. So that's one piece of my solution. Negative 1. I can take that and plug it into either of these equations. Well, since I'm trying to find x, it doesn't matter which one, but that one looks so much easier. I'm going to use that. X is equal to 3y plus 6. So that means x is equal to 3 times whatever y is, but we said that's negative 1 plus 6. So that x is equal to negative 3 plus 6, or 3. That's my solution. So if I plug this in here, it didn't even ask us to put it in the form of a point. You will usually be asked to do that. 3 for x, negative 1 for y. We should be good. All right. Not that bad at all. I don't know why I clicked on that button. I clicked the wrong one. Sorry.